What if we take this straight wire we just studied about and bend it? So here I have a straight wire bent. So we know that the magnetic field is going to be concentric. That will not change, right? That will not change. What will change is the net effect. If I keep doing this, right, at the middle and all of this space, each of this section will have its own influence. Similar to how in gravitational field and electrical field, we saw that every particle, every mass, every charge has their own influence for a given space, right? You remember this? Say we consider 2 points and we find out what is the net field, electrical field over here. Similarly, there will be a net magnetic field in places. So here, we'll have everywhere actually net magnetic field. So the question is, what will be the overall pattern? How does it look like and what will be the strength? So let me show the pattern part. So a simple setup, homemade, no current, a small compass, and let me move it across. Right now there is a current. Now you can see the deflection, same stuff. We have circular, no, concentric circles. Can you see that? So the current is going down. Think about it. Here, my question is on the right end, is it going down or up? Is the current clockwise or anti-clockwise? As per this direction, it's supposed to be, if that is the direction, it's supposed to be down, that is clockwise. Yeah, clockwise. Okay, let me continue. Now, you can see the pattern on the right hand. So even if we put, again, if we use our right hand thumb rule, so my magnetic field is like that. Yes, it's coming out to be the same. Again, try to use your right hand and pause and figure out what is the direction of the current. This is the point wherein you are learning your basics, making it stronger. Okay, same thing. Now I'm putting it in the middle. Can you see that? In the middle, it is pointing outward and it's bending and bending. So basically, I'm sorry, I should be providing this video and zooming it in. Only then it will be a lot clearer. Okay, I'll try to do that actually. You guys can also do this, what I'm doing, and observe. Okay, I don't know how much clear that is. Actually, I'll make this as a separate, I'll put it as a separate video for you guys to push and pull. The point is, it would be circular, but here it will be denser. Does it make sense? It will be stronger in the middle. That should be commonsensical, and it will be something like this, right? We have seen such thing. So if everyone is coming in this manner, what happens at the center? Yes, it will be almost straight. So that's your pattern. Okay, guys. Now let's look at the magnitude aspect. Let's look at the strength. So let's consider a current loop of wire with radius r. So here the radius is r. That's your center. Next, carrying a current of I. So this is I. So we're examining a small current element. Say we'll consider this small element. According to, so this is going to be your unit, not unit vector, vector r. And that would be your direction of current. Okay, that's your dl. So, and remember, this is always perpendicular. dr and r are always perpendicular. Why? Because this is tangential. This is always a tangent. Again, these are extra bit of information that you guys need not write in the exam. So on and so forth. Now, due to the element, what is given, your dB is given to be, mu naught I by 4 pi, or mu naught 4 pi. I go in this order. It depends on the current, it depends on the length, it depends on the angle, and the square of the distance. Okay. Now, here clearly theta is 90 degree, and that too always. So you don't have to think about any section of the wire which is not going to be part of it. So every element within the circle will be making an angle of 90 degree. So therefore dB will be equal to mu naught by 4 pi I dl by r square. Now the question is, next part is magnetic field due to all such current element. So what will that be? How will we find that? Yes, with the help of integration. Basically, we're adding up. Integration has to do with adding up. So that would be B integrating all of those elements. So when we substitute it, mu naught by 4 pi, it's constant. I dl, I is constant. dl, well, length, that's what we have to integrate. R square, the distance will not change. As R remains same, for all elements, we have B is equal to mu naught by 4 pi I by R square will go out of the integration, and you just are integrating dl. So if we consider our dl as a proper circle, right? I know I didn't draw the circle, so I'll write the case for, actually here, if you see this video, we're having circles, that will be the real case. So we'll have a complete circle for a complete loop of wire. Remember, these are insulated, so we can have non-insulated also, but say this is insulated, so we can arams have, and touching also, nothing will happen. So what will this integration lead to? What if I add all the elements over here? What will be the length, total length? It will be pi r square, is it not? It will be divided by pi r square. Is that correct? Nope, it's wrong. Why is it wrong? It's not area, it's circumference. Is it not? 1s are 2s are r and r. So this will be the strength. Mu naught 2 I by r. This is how it will vary. So if I increase the radius, the strength will reduce. If I increase the current, the strength will increase. So it's a simple expression. So of course, like in my diagram, what if I have n loops? For n such loops, right? With same center, of course. So similar to this. What will happen? Nothing. The effect will add up. So why is this? How can we prove it? Same funda with all the forces and fields that we have studied from past, say, 1.5 years almost. So we can prove it with the help of superposition theorem. That's it. of magnetic field. Right? When you have multiple source of magnetic field, the total magnetic field at any point is the vector sum of the magnetic field produced by each source individually. Okay, so basically this is a vector sum of vector result. Okay, now when it comes to the direction, let's see. So current is going up, it will be in. So magnetic field is in, right? At the center it will be going in. Actually it will be, so basically it would be something like this. Near it is always concentric, that's not an issue, and concentric circles, so it would be something like that. Okay guys, now it's time for you guys to pause and have a look. Okay, so just a second. At the center, so nothing, I just wanted to check something at the same center.